Mm-hmm. I should be able to see my podcast here. Yeah, I can. Wait a minute. I just. I should have one live, right? But I'm not able to see any. How come? Latest populate. Is this? Yeah, I think. This is the one. If I do hi, then they should respond, and I should be able to see hi. Welcome to IC2. Remember, you're okay. Got it. So are you able to see the current problem? Yep. Let's start then. So what I'll be doing in this live stream is basically I'm solving 10 problems of LeetCode, which I tagged for Microsoft, and yeah, I think that's it. I'm basically practicing for upcoming Microsoft interview, and yeah, I just took 10 random problems of Microsoft tag and we will be solving them. Yeah, let's start with first. And how we will be solving them is exactly the same way as will be like if I'm interviewing the for the role. So basically, it is a mock interview type coding session. Let's go with the first question then. Part sum 2. Uh, what is given is given the root of the binary tree and an integer target sum. What is given is we are given a root and a target sum. Sum will be int. Return all root to leaf path where the sum of the node values in the path equals target sum. Each path should be returned as a list of nodes values, not node reference. Okay, so node reference would be pointers to the node, but we don't want pointers. We need uh, the values of each node. Uh, so how we'll get is node dot val. That's how we'll get the value. The root to leaf path is the path starting from the root and ending at any leaf node. A leaf is a node with no children. So given tree node, we have left and right. So how will we be able to say if the current node we are searching is leaf is if there is no left and right pointers. That means basically the left and right pointer of that node will be null pointer. Yeah, so in this example, since the target sum is 22, um, 5 plus 9 is 5 plus 4 is 9 plus 11 is 20, 20 plus 2 is 22. Yeah, so this works. How will this work? Um, this is 12 and this is 10. So yeah, 22. Yeah, I get it. Uh, the thing is, the caveat is you have to remember that they are asking the path from root to any leaf and not any node to leaf specifically. And the problem is that there could be order of n square such paths. So the memory would be order of n square at max. And even the time complexity would be order of n square because I need to keep a track of the path. So is there any way to say that every node val is unique? No, right? They don't give me that. And also, how will I be able to say that if two paths are unique? What if in this question it was 5, 4, 11, 2 and 5, 4, 11, 2? Then should I output the same path? Hmm, it's not given. So let's assume we have to output the same path because yeah, that's how we'll do it. So here 1, 2, 3 and 4. Nothing goes to target. And here 1, 2 target is equal to 0. You cannot get target. The node values would be from -1000 to 1000 and target sum will be -1000 to 1000. Okay, and the number of nodes will be 5 with 3. So I can do n square easily, right? How I'll do it is um, I'll I'll do a DFS from root, and every time I go down a level in the DFS, I will add that node to a vector of the current path I have traversed so far, and I'll also update the target sum, the current sum, and if at any point I see a leaf and the current sum is equal to target sum, I will I will add that to my answer vector. Yeah, to my path vector. Uh, one thing to be clear is that since I'm practicing for interview, I'll also have to make the variables as descriptive as possible and not make them like I don't have to name the variables in competitive programming way. I have to make them descriptive. And one more thing to also keep in mind is to have to have um, let me think. Yeah, to have helper functions and not to overcomplicate a single code. To always have more helper functions. So let's start. I think I'll do DFS. Yeah, let's have a vector int. Yeah, in public it's fine. Vector int valid paths. This I will return here. Return valid paths. Let's keep this and do oh, this works. Then let's make a DFS void DFS. What this will have is one more thing to think about is will my sum ever go beyond int 5e3 times 1e3 is 5e6 and it will be under int comfortably. So let's have tree node star node and int current sum, yeah, current sum and vector int current. Oh, I don't have to do this, right? Current path. Or do I have to do this? I can do this. It would be more efficient. Uh, so if I pass it as reference, I'll have to pop the things when I go up. Like when I do a DFS, I go to that node, right? And when I return from that node, I'll have to pop that from the current path. I think you get that. If let's so I could have 0 elements too. So if node is equal to null pointer, then I just return. And if node This will be my base case. Node dot left is equal to null pointer. This will say that I'm checking here that if this is leaf node and current sum is equal to target sum. So I also need target sum here. Somehow I can, or else what I can do is I can pass here target sum and check if target sum is equal to 0. I'll decrement my target sum with the current amount. I think you get that. And why am I not passing this as by reference is because it's easy to like copying the integer is not that hard, or what I can say is it will not take much time, but copying a vector may take much time depending on how many elements you are copying. So passing integers by value is okay. Node dot right is equal to null pointer and target sum. Oh, I have to put an and here. Target target sum is equal to, if target sum is equal to 0, 1 minute, then valid paths the push back current path. Yeah, I think this will work. Yeah, it will work. Should I do employees back? What will employees back do is it will take this vector as a reference and make a copy of it. No, not copy. No, I think I will not make it. I will not do employees back. Or should I do employees back? Let me think what employees back does. Employees back is when you have to push something in vector and you don't have the object and you want to create that object in the vector, then you do employees back. But if you have an object, you do pushback, it's fine. Yeah, then I'll do pushback. And here return. After this, even if I don't do return, it's still fine. DFS node dot left, comma, target sum, minus, mm, what should I do? Uh-huh, uh-huh. So basically what I'm thinking is, what should be my way to update target sum? Should I update it at the start or anywhere else? I can do that here too, and then this will be updated. Then when I pass root, I also have to do target sum minus root dot val. And if I do it here, then I don't have to do these things. I can just pass target sum and check if minus that is good, if is good enough. But then I still have to pass it here, right? This has to be updated, basically. So I'll just, I will update my target sum when I am passing it to DFS. Let's do it first so I don't forget. Target sum minus, but then this won't. This is useless then because I have to check if the root is not equal to null pointer. So in a pass, yep. So I'm checking if root is equal to null pointer, return just an empty. No, this won't work. Minus root dot val, comma, current path. Current path could be vector int current path and current path dot push back root dot val current path, and here I'll use current path dot push underscore back node dot where dot val, and then I do have to check this if node dot left is I can just check if it is not a null pointer by just doing this, and node dot left dot val. After this, let's pop back when we come out of that DFS. Target sum minus node dot left dot val and current path. This will work if node dot right is not equal to null pointer. Then do the same thing. I'm just copying it. Node dot right. Yeah, I think will this work? If node dot right is not equal to null pointer, decrement my target sum. I think this should work. Let's see. Oh, compilation error. Yeah, it works for these test cases. Let's see if it works for everything. Yeah, it works. On to the next question then. Maximum width of binary tree. Given the root of the binary tree, return the maximum width of the given tree. Okay. The maximum width of a tree is the maximum width among all levels. Okay. I know it is a binary tree first thing. Binary tree thing means that um, it will have 0, 1 or 2 children. The width of one level is defined as the length between the end node and between the end nodes, the left, the right, the leftmost, the rightmost non-null nodes, where the null node between the end node that would be present in the complete binary tree. Oh, whoa, whoa, whoa. I didn't get it. It gets through. Again, the maximum width of, okay, I get that. The width of one level is defined as the length between the end node, the leftmost and the rightmost non-null nodes, where the null nodes between the end node that would be present in the complete binary tree extending down to that level are also counted, okay, into the length. Okay, so this should be 4, right? Because even if there is a null node, it would still be counted. So if this was not there, this would be 3, the leftmost and the rightmost. the leftmost and the rightmost. Okay, this thing gets this will be 1, 2, 3, 4, 5, 6, 7. Yeah, I think it will be 7. Mm-hmm. Mm-hmm. What if there was nothing here and there was just this or this? Then it would be this would be 6 and this would be 5. And how will I be able to check these is going left. Um, hmm Let me think. Let's first have the height. Height would be, let's calculate the height of this. So it is 0, 1, 2, 3. What will be the case for these? I'm thinking about that. What if it's more like this and this is not red? Only this is red. And um, node val, 3 inch of nodes in tree is in the range. The number of nodes is 3000. So that val is minus 100, 200. But node val is irrelevant, right? I am just, the only thing that matters is how many number of nodes are there. That val is irrelevant, so you can just remove it. The maximum. This will be this and this. Okay. This minus this plus 1. Okay, the length. So here would be 2. If there was something here, then it would be 1. If so, there was something here, it would be 2. Uh-huh. What if I do an encoding? What if I knew what was the one thing is I need the height, and second is what would be the value of this node if this was a complete binary tree. So this will always be 1 no matter what. This will always be 2, this will always be 3, this will be 4, this will be 5, since this has nothing to the left. And this was the right side. So this is, wait, let me think. This is 1, 2, this is 3, this is 4. Is it 3? Yes, it is 3. And this is 4. This would be 5. How will I get 5 from, let's do this. Let's do it here. I have a node and another node. Oh, and another node, another node, another node. Let's do it for this first. This way. Oh, no. see. Where is this? It have one here, have another here. Oh, hmm. I'm sorry, I'm new to this. Bear with me. No, this won't work. I have to manually do it. And um, let's say the first one is 1. Can I lower stroke width? Yeah. Still, I need lower, but I cannot write. This 1, this is 2, this is 3, this is 4, this is. Oh, wait, I did something wrong. 1, 2, 3, 4, this is 5, this is 6, and this is 7. So I have to find a way such that I can code them in this way. So 1, I know that, and if there is 1, I can do +1 +2, but that won't work here. Times 2 times 2 plus 1. Yeah, times 2 plus 1 times 2 times 2 plus 1. I get it. It was easy. So I have to find for each height what will be the minimum and maximum. And how will I find the minimum and maximum values? Just let's just focus on finding the value for each finding a value for each node, and then we'll find the minimum and maximum for each height. Uh, for each node, we can go 2 times, if we are going left, 2 times the current, and if we are going right, 2 times and 2 times the current plus 1, current value of the node. So this is going left, 2 times the current value, 1 is goes to 2. If I'm going right, 2 times the current plus 1, this is 2 plus 1 is 3. Yeah, this is times 2 6, times 2 plus 1 is 7. This works. If I'm going here, it will be the same logic, right? This will be 8, this will be 9, 10, 11, and so on. I'll have this, and then what I can do is I can have the maximum height I can have seen so far. um, yeah, I can just have a variable which will be the maximum height I've seen so far, and I can make a minimum and maximum array out of it. For each height, I'll find the minimum, the node which has the current height, which, and I'll find the minimum of all of them, and same for the maximum. Yeah, that is my plan. Let's implement it then. Let's do first a DFS to find. Should I have a? I need a count of every. Hmm, I need the count of the whole total number of elements. And how will I find the count? Hmm, I cannot find the count. I'll have to do a first DFS int n, which will be equal to 0, and then do first DFS to find the count DFS. Root void DFS tree node star node n plus plus if node dot left. What is Yeah, I know that at least root will not be equal to null pointer since the leftmost limit of the number of nodes is 1. If leave dot node is not equal to null pointer dfs node dot left, if node dot right is not, this is how we check if anything is null pointer or not. We just have this, or check check it explicitly as this, but this one, this, oh, so yeah, not equal to, check this, or else just do it like this. If dfs node dot right, this works, I'll get my n, and let's do dfs2. mm, let me think, let me think. This time I will need, should I also encode each one? Should I? Actually, no, I won't be able to encode them because vowels are different. But I know every address of pointer will be different. Vowels can be same, but pointers to the address will always be different for different nodes. But can I do it better way? I don't want to do it with M because then let's have two vectors and populate them. Vector int height, and what this other thing is, value, and do void dfs. Tree node star node, and let's have int ht current height equal to 0. Um, this is this is something that you can do if like this allows you to not pass the default height or pass any height here, and if you don't pass any height it will be equal to 0. If you pass some height, it will be the current height will be equal to the thing you passed, the value you passed. And here what I'll do is wait a minute, why need to, how will I populate height? That's the question. What else can I do for each height? Let's have int max height I can achieve as -1, and max height equal to maximum of max height and current height. After this, what I'll do is vector vector int value for each height. I'll store that, or else I can have is int minimum, vector int minimum height, minimum val, maximum val. I'll do the maximum height, and then after that min val dot resize max height plus one, and max val dot resize max height plus 1. And after this, what I'll do is I'll do dfs2 of root, and here I'll do the logic for calculating the val, void dfs2 tree node star node comma int current val. Current val will start with 1, and I'll do the logic part. Let's do this first. If node dot left is not equal to null pointer, DFS node dot left comma current height plus 1. If node dot right is not equal to null pointer, node dot right comma current height gist plus 1. Yeah, works. Here, what I'll do is I will also have to calculate current height for each node now. Just copy this. I don't need this. DFS2, current height plus 1, 2 times current val, so 2 times current val plus 1. Here, I'll do is min, dot resize, since this is, this has to be 0 for 2e, since I need minimum 29, and since I need maximum is minus 1. This works. And what I'll do is min val of current height equals to minimum of min val of current height comma current val comma current val. This will do max val will be the same, right? So just copy this and change min to max. Yeah, this works. What I can do now is check for int I equal to 0, height equal to 0, height less than max height plus 1, height plus plus. Then let's have int, what am I, max width 0. I know that will be, it can be 0, right? When you have just one node, then left and right are same, right? Yeah. I also have to assert this, that assert min val of height is not equal to minus 1 and not equal to 29, and max val of height is not equal to minus 1. Since there will be at least one valid value for each height, and that will be the thing that is reflected at the minimum. And max width will be equal to maximum of max width comma max val of height minus min val of height plus 1, and return max width. Let's see how this works. Get max height. If you cannot, okay, equal to minus 1, they should work. What are other errors? Maxwell dot tree size go. Yeah, this passes. Let's see. Oh, runtime error. Find integer overflow. No, but they said that would be under. Okay, okay. If I go down each step, students. What if everything is right? What if even everything is left? And three times. Oh yeah, true. I cannot do 3,000 times. To the power of 3,000 is never possible, right? So I have to optimize this to fit under. Mhm. What if there is? What if there are 1,500 nodes used for the left and 1,500 nodes used for the right? Then, but they say that they are guaranteeing that it will be under in int. In, hmm. How will I be able to? Hmm, hmm, This is something to find. How will like if it was just two times well every time, then what I can do is just store the number of the power of two, but it is not always times two. So one operation is times two plus one. So left shift plus one, and the other operation is left shift, left shift, just left shift. Is this not true? Yeah, it is true. So can I have a bit set? But bit set is bit set would be expensive. Expensive. Actually, it will be expensive. Bit set of 3,000. Expensive, obviously. What other things can I do? What other things can I do? What if I go 100 to the left and 100 all to the right? And to take the right child every node. Can I somehow, for each level, can I somehow, let's think, for each level, can I somehow, hmm, hmm. If I do it that way, that I decrement 2 to the power of height from each node in the current height level, I know I'll get that the value in zero, starting from zero and incrementing. But can I guarantee that it will still be under int? What if there is something like this and something like that, wherein no, I cannot guarantee that. Might not possible. Even if I just remove that, it's still not possible. Or is it? Hmm. What if I minus this with one left shift? Um, Let me think. If I have two here and height is one here, right? The here height is zero. Here height is two, and one left shift two is one left shift two is hmm. I'm thinking, what if I take a modulo? Will it still be? What if I take modulo 1 in 9? Then when I decrement them, when I when I subtract them, will it still be the same? Let's think of it, right? Why not? Let's say I want to find 3 minus 4 whole mod some prime. This is minus 1, and when I this will be p minus 1 when I do mod, right? Hmm. Hmm. And I think mod doesn't affect it. Well, let's see. Why not? Const int mod equal to 1 in 9 plus 7. Um, percentage mod percentage mod. But then min-var and max-var will not be what I wanted them to be, right? What if min-var goes below? I have no control then. True. Hmm. Can I find some other way? Like, doing this would be disastrous. Can I somehow find some other way? One, two, two, four. Hmm. Mm-hmm. I know that each time I go to the left, I left shift. Time I go to the right, I do left shift plus one. Mm-hmm. But I cannot find the actual values. Hmm. So what I'm thinking right now is there a better way to find the values without computing them, without computing the actual values? Hmm. Hmm. I have one case wherein what if the left part was all empty, null pointers? Then what? How will I be able to find? If two were part of the same thing, then it's easy to find, right? What if I can merge two things when I come here? So I know when I'm here, when I return from here and return from here, I can give some information, right, about these and these. This will be times 2. Anything here will be times 2. Anything here will be times uh, anything here will be times 4 when I this goes to here. Anything here will be times 2 when this goes here. Anything here will be times 2 times 2. When this goes here, it will be times 2 plus 1. But if there was a 1 here, this will be 3, and this will be when I go from here to here, this will be times 2 plus 1, right? Yeah. Okay. Okay. So when I return from somewhere, what I can do is for each level, So this will have, when I'm returning from here, this will return the vector int, and it will have only one element, which will be the one. Everything here will have one element, right? And when I'm returning, I'll say if in this will also have vector int, and it will have only one vector, which will have one in it. And then, oh, I don't really need vector int. I just need vector of pair of int comma int, left and right. That's fine, right? And when this returns here, this will be, since this was the left, it will be just times 2, anything here, the left and right. So left and right will be 1. So left will be times 1, right will be times 1. This will also return 1, 1, but since this was right, it will be times 2 plus 1, times 2 plus 1. So this will be 3, and this will be 2 for this. And those will be the second elements for this. So then in here, this will only have sorry, it will be only 1 comma 1. This will also be 1 comma 1. This will be 1 comma 1, but there will be another element. uh, this will be 2 comma 3. True. And this will be 1 comma 1. This will be, let's erase these first, and these. This will be 1 comma 1. Can I do this? Yeah, I can, right? This would be 1 comma 1, and another element will be, oh no, let's do this. And another element will be 2 comma 3. And when I go here, this will be 1 comma 1 comma this one's first element, this one's first element will be, this one's first element will be 2 comma 2, this one will be 3 comma 3, and taking the minimum for the left and maximum for the right is 2 comma 3. And here this will be 2 3, this will be 2 3, taking the minimum from the left, uh, from both, right? So this will be 4 here, and this will be uh, times 2 plus 1, right? Yeah. Oh, wait. Since this comes from right, plus 1 times 2, I think. Oh no, times 2. If this is times 2 plus 1, then this will be 5, and it is not true. And this, the returns, should be this, not right. And when this returns, it should be 4, and this should be 5. And when this returns from the right, it should be 6 and 7. Okay, and how will I calculate that? Times 2 plus 1, times 2 times 2 plus 1. If I do just add 2 times 2 plus 1, it won't work right. Yes, this will be 4, and times 2 plus 1 is, this is 7. But even if there was just 3, let's say just this was not present, then this should be here, this here. And what would that be? Is 3. It should be 3, right? How will I get 3? When I go back, one, 1, and then 1, 4, 1. How can I represent it? How can I represent it? I know that when I go up, when I go down to the left, I know it was a left shift operator. So going up would be the right shift operator. Hide is important, I think. So here's what I have to do. That will be 1, that will be 1, 0, 1. 5 is 1, 0, 1, right? They should correctly represent 4,7, right? But even in this case, it's still theory. It will still go beyond law int, right? is have no way to control them. True, 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 true. True. I think like I'm overcomplicating things. This is a good example. Oh, can I have for each one what was the path I took? Left, 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 and right, right, left. Um, so what a left, 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 and right, right, left have? Mm, I can just, can I know from this what would be my, hmm, can I know from this what could be my answer? So if left and right, one, one greater, right? The three greater. I know the leftmost parts will be same because it has to come under int. So left, 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 or right, right. Let's say right, right. Mm-hmm. Times 2 plus 1 times 2. Left is times 2, so 6, and times 2 plus 1 is, no, it's just times 2, so 7, 14. Oh, times 2 is 8, broken. And then 14 minus 14 minus 8 plus 1. 14 minus 8 is 6, plus 1 is 7. Okay, I get it. If something has a left and a right, if the left, anything that is in the left, can I make the answer greater if, no, not true, not true, not true. So, is this a clue that if something goes beyond this, I don't have to look more? Well, let's see the tutorial at this point. I think I'm wasting my time. The key to solve the problem quicker lies in the node that I on the scene node. Suppose that in this first and the last node, C1 and C1 respectively, we could then calculate the width of the server as Cn minus Ci plus 1. Okay, this is all we create. Okay, okay, okay. This is at the end of the hey, wait. But then this goes beyond values that should vary 2 times, won't work. Hey, if he can do it, then why am I not able to do it? Should I do long long? Then how come they are able to do that? Plain. Hmm. How though? How? If he can do it, how can I not do it? Hmm. Very close binary tree. Okay. Define TFS. Mm-hmm. Hmm. So this won't work, right? About that, what we can do is we can do. What can we do? What can we do? What can we do? I mean, we'll skip this question for now. I'll get back to this later. Let's go to the next question. Maximal network rank. There is an infrastructure of n cities with some number of roads connecting these cities. Each road I is equals to a comma bi indicates that there is a bidirectional road between cities ei and bi. The network rank of two different cities is defined as the total number of directly connected roads to either city. The network rank of two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. Okay. Of the infrastructure is the maximum number of network lines of all tiers of different cities given the internal and integer n and the array roads within the maximum network range. The entire infrastructure. Okay. Mm-hmm. Wait. Since n is very small, given the rate on the maximum network of the entire infrastructure, so it is 0 and 1 is 4. 1, 2, 3. So 1, 2, 1 to 3, and 1 is common. So, okay, here, if this one is 1 to 3, this one is 1 to 3, but 1 is connected. 8. There is something. The network around of 2 and 5. Can I get something better here? 1, 2, 1 to 3. No. 3. My intuition is if there are two, let's say each node has some number of edges. So if there are, let's say the maximum connectivity of a single city is, let's say mx, maximum, some variable max. Okay, so my intuition is that the no, okay, if there are two or more than two elements or cities which have maximum connectivity, then my answer will be maximum 2 times maximum or 2 times maximum minus 1. So if I sort to sort, if I have a sorted array of connectivities of each cities, then my answer will always be the maximum and the second maximum, add both minus 1, or else if there are multiple second maximums, then if it could be 2 times, no, it could be maximum and maximum minus 1, the second maximum and the first maximum addition, or else how can that be the case if if two are not connected? If they are connected, then it will be minus 1. Yeah, I think this is quite easy, and also the n is quite low. I can do order of n square and cube. But what is the roots? It's n square, right? It would be 24. So given 24, let's first, how will I find the n? And how can I find n? 0, 1, 1, 2, 2, 3, 4. Let's have an area of int vector int count of 100, 10, 5 for auto ampersand u comma v in, oh no, I cannot do that, right? For auto ampersand pairs in roots for auto ampersand u comma v in pairs. Count of u plus plus count of v plus plus and vector int or a pool. That's a pool of, should I do this? Yeah, I think I should. Is connected of, let's have a variable, right? Const expr int n equal to 185, 182 plus 5. N comma vector pool n. It will default to 0, so don't need to worry about that. Is connected of u comma v is equal to 1 and is connected of v comma u is equal to 1. Or else just have it one way. For convenience, let's have it both way. After this, let's make another array, vector pair int comma int. Connections for cities for int I equal to 0, I less than n, space if count of I, not count of I, that means if count of I is equal to 0, continue, else connections for cities dot push underscore back count of I comma I sort this dot begin comma this dot end, and can I go? Yeah, I can do it, right? For int I equal to 0, I less than n, I less than n, I plus plus, I less than connections dot size. For int j equal to 0, j less than connections dot j less than I, let's say j less than I, j plus plus. Int answer will be 0, and answer can be maximum of answer comma int count I equal to connection of city of I dot first int count j will be equal to dot j dot first int index I equal to of I dot second int index j equal to connection of j dot second. Count I plus count j minus is connected, right? Is connected of index I comma index j. And return this. Yeah, I think this works. For compilation error. For a you can be, oh, yeah, true. What I can do is int u equal to pairs of 0, int v equal to pairs of 0, pairs of 1. And remove this. Network fine. Let's go to another one. Implement router. Design a data structure that can efficiently manage data packets in a network router. So I have to manage data packets in network router. Each data packet consists of the following attributes: source, a unique identifier for the machine that generated the packet; destination, a unique identifier for the target machine; timestamp, the time at which the packet arrived at the router. The packet arrived at the router. The time at which the packet arrived. Okay. Hmm. Implement the router class. Router int memory limit. Initialize the router with the fixed memory limit. Memory limit is the maximum number of packets the router can store at any given time. If adding a new packet will exceed this limit, the oldest packet must be removed to free up space. Bool add packet int source int destination in timestamp add the packet with a given attribute to the router. The packet is considered a duplicate if another packet with the same source and destination and timestamp already exists on the router. Return true if the packet is successfully added. That is, it is not duplicate, otherwise return false. Int forward packet. Forward the next packet in FIFO order. First in first out. Okay. Remove the packet from the store. Read. Return the packet as an array. Source destination timestamp. Forward, right? Forward. If there are no packets to forward, return an empty array. Okay. Int get count in destination, start time, end time. Return the number of packets currently stored in the router that is not yet forwarded that have the specified destination and have timestamp in the inclusive range. Okay. Queries are for packet add packet in non-decreasing order of timestamp. Okay. Add packet. Mm-hmm. Let me first see the ranges. Source and destination will be 2 5 times 10 at most 25 calls will be made to packet, add packet. Okay. So source and destination, I have to know that when I'm doing add packet, I have to know that if that source and destination and timestamp was already added before and is in the router. If it is in the router, then I will not add it again. And since my memory limit is 25, I cannot check each and every element again if the current thing that I'm adding is already in the memory. Yeah. P4, this works, and also if I reach memory limit, then add packet will also remove something in P4 and add the new thing back at the back. Int get count, so time and time for add packet will be made. Another it will get got it. Mm-hmm. Uh-huh, good. So I'll have the previous timestamp. If the current timestamp is the same as the previous timestamp, then I have to check if there was a duplicate. Okay? Since timestamps are increasing, I can do that. For each timestamp, I can have a map, right? But clearing that map would be so. Can I clear that map? I guess I can. I can. But I cannot search the whole map. Or if I had a vector, then I cannot search the whole vector again and again for the same thing, right? True, true. What if I had a set? Set and map are same thing, right? Yeah, set works. You said that file source comma destination is not equal to null pointer, return false. And if timestamp is not equal to previous, it increment it, then reset the set to empty. Yeah, I can do that. Set pair int comma int source des destination for uh, yeah, source destination pair int previous timestamp. I can do these, and then also I can um, I don't know when I'll get this get count. So for each destination, so I'm doing time. Mm, should I store for each destination the timestamps? Timestamps? Yeah, I can do that. Two five, right? Because destination can be 2 5 at the worst case. So vector int destination of and not like this. So, hmm. And then I can do get count, doing two lower bound one. Yeah, I can do it in log and this. Um, how will I check? I will get forward. I also have to get this right forward. Forward. How will I check for forward? Can I have a vector int and yeah, I can have it, right? I can have a vector int. Memory int memory limit and then memory limit. Let's have this as underscore equal to this. Um, should I? Yeah, previous timestamp. equal to -1. If time stamp is not equal to previous time stamp, else time stamp, no, previous time stamp equal to time stamp. I think this will be my last question today. I'm tired. Timestamp is not equal to previous timestamp. I have to do times. Ah, this that clear. This that clear. Then this should also insert source comma destination. Hmm. Okay. And destination dot push oh the one timestamps destination timestamps so push underscore back timestamp. Yeah. Um, else if both are same, if um, source destination pair that find source comma destination is equal to dot end, then or else. If this is equal to end, that means it is not present. Else, I don't have to. I just have to return 0, right? Return 1. Here also I'll have to return 1. But first, since timestamps are seen, I'll do this. I don't have to check for timestamps. Source destination. Yep, this should be done. And don't need to do this. Don't need to do this. Yeah, works. Oh, also, when I'm doing this, then memory dot push underscore back source destination comma timestamp. Also here I have to do that, right? Um, Other than that, I think it's good. Here, uh, also I have to check, right? If memory is here and also here, that if memory is full, if memory limit is equal to is less than memory dot size. Int first source equal to, oh, it should be q, right? Q. This should be Q. So it should be push memory dot front int first destination equal to this comma 0, this comma 1, int first time stamp equal to this comma 2. Then memory dot pop if first time stamp is equal to um, time timestamp, then s source destination pair dot erase for source from first destination. This will be login. If yeah, it should be the same for this too. If memory in first destination memory, okay. This should also be push. Looks good. Thanks. Yeah. I think this will never be the case here because yeah, I think this will always happen. This will always happen since we are updating the timestamp at current time. Yeah. This export forward packet. Here I can check if if source destination pair. Oh no, if memory dot size, if memory dot empty, return empty vector. Else, let's do this and if previous timestamp, what was the variable's name? If previous timestamp, yeah. If previous timestamp is equal to first timestamp, then uh, then I have to remove that from pair, right? Dot erase. The same thing. But then this should be this should be so when I'm finding for print when I'm doing get count, remember currently stored, right? So it should Okay. So I think this should be setting. Multi-set. So if something is removed, that is that fine. I have to see for remove the packet. Okay. Then I'll remove it. Then get control V. Destination timestamp dot lower underscore bound and dot upper bound and time minus destination timestamp dot lower underscore bound of start time. This is returned. Hmm. Yeah, true. Everything should be for destination. Hmm. What is the error? I know what the error is. That there's a there's a not non-indexed set and I'm accessing it. I cannot do iterator. I cannot write it over not set. Can I find a better way? This is way too clunky. For each destination, I have to find the start time and time. But the number. the number of packets currently stored. I know that whenever I remove some packets, it will be always be the first ones that will be removed. So I can have a queue, right? Queue, source destination here. No. It should be destination timestamp. Dot push dot push dot pop. I have to check. Can I do the were found on queue in C++? No, you cannot directly. Okay, so I have to convert it into integer, right? Or else I can have index, right? Int current index will be equal to -1, equal to -1, and I have it as vector, and that push back. If I'll do push back, keep this as 0, and this should also be push underscore back. This should be pop underscore back. Oh no, I don't have to do this, right? Current index plus plus, I'll do current index plus plus. So it should be 0, right? Yeah, 0 plus 1. So that would be my first index. Then here, what I'll do is get int hello equal to in current index, int high equal to what am I finding here? First, I'll find end time minus start time, right? So end time, what I'll find is the first element which is greater than end time. I can do it right. I can do this, right? Int destination that bound end time minus, yeah, I can do this, but there is one caveat that that what if these are int are, what if these are greater than, what if these are less than index, current index? Is this minus destination dot begin int l equal to this minus destination of begin, and if l equal to maximum of l comma current index, Same with r equal to maximum of r comma current index. Return r minus n. What if there is nothing? November per bound. Vector int. So is it upper bound like this? No, it's like this, right? I don't remember. Up underscore bound. I'm doing this. Oh yeah, it's upper bound. And that begin, comma, destination dot end, comma, and then this is how it's done. Destination dot begin, comma, destination dot end, comma. Yeah, I think this will be fine. Current index, this one. Output, good card, 1, 2, 3, first destination, this, but then this has to be removed, right? It should be here, 333, CM. Let's, let's see. In this scenario, there should be one, right? And here also current index should be first first. I did not do that. This should work. Yeah, it works fine. Math, what am I doing? So, I get count, forward bracket, get count. How come? Oh, the current index should be for each current index of n. Vector int current index. And the current index should be for each destination, right? Current index of destination purpose. Okay. Okay. What happened? Unknown. Type name. Oh, come on. How is it unknown? Context. Oh, okay. Tree. Even this now, this does not work. Oh yeah, current index destination. What about this? Works. Oh. 1, 2, 3, 4, 5, 6, 7. The get count is around here, right? 1, 2, 3 works. Then the count does not. 1, 2, 3 works. Then get count does not. This should not be the case, right? It should be done every time. Quite a hard question. Can I do it better? What should I do to make it better? 2 vector int. I can do parent command here if I want. Destination timestamp. Append. It's fine. 1, 2, 3, 4, 5. So I've done 4 questions maybe. Let's do this last question. You are given an array nums consisting of array integers between the triple sequence of elements in nums such that those elements all have the maximum frequency. Of an element is the number. Oh, return the total frequency of element in nums such that those elements all have the maximum frequency. The frequency of an element is the number of operands. Okay. 2 have a frequency of 2, which is the maximum frequency. So the number of elements in with maximum frequency is 4. Okay. Yeah, I know what I have to do. Map int from my int or else int vector int ctr count of 105. For int equal to 0, I get then nums.size equals first nums of count of nums of 5 plus plus for int mx equal to star maximum underscore element of count dot begin comma count dot end for int I equal to 0 5 less than 105 I plus plus let's say int answer 0 count of I equal to mx answer plus equal to x return answer. Yeah, I think that's it for today. Stream. Bye bye. Have a great time.